Lesson 37, useDeferredValue. 1. Introduction. Good morning, afternoon everyone. Today we're going to explore a powerful tool that React provides to help smooth user interactions and improve responsiveness when parts of your user interface are heavier or slower to update. The hook is called useDeferredValue. My goal is to explain what it does, why it matters, when and how to use it, and what to watch out for. 2. What does useDeferredValue do? At its core, useDeferredValue allows you to take a value in your component, for example a user input or a filtering term, and tell React, okay, this value may change immediately, but one part of the UI that depends on it can be allowed to lag behind for a little while. In other words, you continue to update the fast-changing part, such as the input field, instantly, and defer the slower part, such as a large list or chart, so that typing remains fluid. During the initial render, the deferred version of the value is the same as the value itself. On updates, React will render with the new value in the main UI, but the deferred value will remain as the old value for a moment, giving time for the slower UI to catch up in the background. 3. Why is this useful? This capability is especially helpful when you have two competing demands. You want immediacy for the user's actions, for example, the user typing into a search box. At the same time, you have a heavy update, for example, rendering a large list or fetching and displaying data based on that input, that could block or slow the UI and thus degrade the experience. By using useDeferredValue, you prioritize the fast path, typing, and deprioritize the slow path, list rendering or data loading. The user remains responsive. The heavy UI update happens without interfering with immediate interactions. 4. When to use it? You should consider useDeferredValue when you have a part of the UI that depends on a rapidly changing value, for example user input, and is expensive to render or update. You want to keep the input or primary interaction instantly responsive while accepting that the dependent UI may update a bit later. The slower part of the UI can show stale content for a brief moment, and it is acceptable to the user that it catches up slightly afterwards. If your UI is already very fast and inexpensive, or if you cannot tolerate any lag in the dependent UI, then useDeferredValue may not bring benefit. You might instead focus on optimizing the heavy UI itself. 5. How it works, at a high level. Here's a conceptual breakdown of what happens. When the value changes, React triggers a re-render of the component with the new value. The hook returns a version of that value which initially remains the previous value, so the dependent UI still sees the older value. Meanwhile, in the background, React begins updating the deferred value to the new value and will re-render the dependent UI when ready. If new updates continue to arrive, for example, the user keeps typing, React may abandon the pending background update and start a fresh one with the latest value. That means it does not queue many outdated renders. It always tries to show the latest possible. Because of this behavior, the dependent UI lags behind the input and then jumps to catch up once ready, without blocking the typing or primary interaction. 6. What to watch out for, caveats and best practices. There are a few important caveats. The hook does not delay network requests or the logic that initiates them. It simply defers when the UI shows the new value. So if you rely on this hook to reduce network load, that expectation may be misplaced. If you pass values that change on every render, for example freshly created objects or arrays, the hook may cause unnecessary background updates because React will detect them as different. It is better to pass primitive values or stable references created outside rendering. If part of your UI is heavy and you want to defer it, you still need to ensure that component is optimized, for example by avoiding unnecessary renders or by memoizing it, otherwise you might still suffer jank. The hook helps with prioritization, but does not magically speed up the heavy component. It's not a fixed timer or throttle mechanism. it adapts to device performance. On fast machines, the lag may be imperceptible. On slower devices, the lag may be larger. That means user experience may vary by environment. 7. Practical guidance in summary. To use this hook effectively, identify parts of your UI where user interactivity must remain fast, inputs, filtering terms, etc. Identify parts that can tolerate a slight delay, large lists, charts, search results, etc. Use the hook to wrap the value driving the slower UI so that React knows it can prioritize other updates first. Ensure the slower component is designed to reuse work when possible, e.g., via memoization or other optimizations. Optionally provide visual feedback, for example dimming or showing a stale indicator, so the user knows that the UI is catching up. Test across device types. Ensure the experience is acceptable on both fast and slower machines, browsers. 8. Conclusion. In closing, useDeferredValue is a thoughtful addition to React's toolkit for balancing responsiveness and rendering cost. It does not replace performance optimization entirely, but it empowers you to give users a snappier experience even when part of the UI is inherently heavy. By deferring less critical updates, you improve the perceived performance and keep the interface feeling fluid. I encourage you to think of it when you build interactive UIs with potentially expensive updates, and to experiment with it alongside other performance techniques. Thank you for your attention. I'll now open the floor for any questions or discussion around uses, edge cases, or your specific scenarios.